Okay, in this video, we're going to look at question number 3. What is the goodness of fit and interpret it? So remember, we're talking about in the lecture about the steps to do the regression analysis. So you always get your regression equation first, and then after that, and then you need to test out the goodness of fit your model, basically to see how well the model you built here fit into your data set. So we call it goodness fit. So the statistic we use to measure the goodness fit is also called the R-square. Okay, R-square. So the key for question number 3 is where to find R-square from your regression output, and then how to interpret it. Okay, so if you haven't watched the video related to question 1 and 2, especially question number 2, please watch that one, because what I will show you in this video is our regression output. From that output, we just need to know where to find the goodness of fit and how to interpret it. So if you don't get your regression output yet, please watch the video related to question number 2, because you will be able to see how to get that the regression output I'm going to show you here. Okay, so like I said, in question number 2, we're able to developing this regression output. So the question is, where is my goodness fit? So the goodness fit is measured by the R-square, which is here. So we have two options, R-square and adjust R-square. So in our lecture, we mentioned that if you want a comparing model, we prefer to use adjust R-square. If you are not a comparing model, feel free to use R-square or adjust R-square. Okay, here I'm gonna using both to show you because I will actually want to help you to comparing our simple linear regression model versus our more complicated multiple linear regression model. We try to make a decision on which one is better. Okay, so both of them here. Okay, so here is measure goodness of fit. And then, like I said, if you are comparing two models, you should use adjust R-square. If you just look at one model, feel free to just use R-square. So my R-square is the value equal to 0.8799. Okay, question number 3. Goodness of fit is R-square equal to, usually we like to convert it to percentage. Okay, because if I keep 4 decimal places, it's 8799. So if you go back to look at my Excel, right? So 87.99. Like I said, it also can be our adjust R-squares. So goodness fit (87.82%) when we need to compare different models. Okay, so we will use the second goodness of fit if you are trying to compare in different models. Okay, if not, just use our R-square. Let's look at how can we interpret R-square. So in our lecture video, make sure you watch it. We learned that how to interpret this one, so we are implement that idea to implement here. So basically, R-square is telling you what percentage of the variation in your y variable that can be explained by your regression model. Okay, so basically, if you want interpreting this R-square, it will be 87.99% variation in the housing price, right? Remember, housing price is my y variable, right? Can be explained by the regression model. So that is how you can interpreting your R-square. So very similarly, if you want to interpreting adjust R-square the same way, so that would be 87.82% variation in the housing price can be explained by the regression model. Okay, so before I end this video, I want to call out why I mentioned when you're comparing model, you need to use adjust R-square. So if I go back to look at my Excel file, okay, so my adjust R-square for the multiple linear regression model is 87.82%. if I'm going back to my simple linear regression model, if you want to compare whether the simple linear regression model is doing better than the multiple linear regression model in this case, you need to look at adjust R-squared. So for the adjust R-squared for the simple linear regression model is 51.12%. It's way smaller than the multiple linear regression model. Therefore, we believe our multiple linear regression model are able to fit in the data better. Okay, remember for the R-square, it is between 0 and 1, and so the larger the better. So as you notice that for the adjust R-square, our multiple linear regression model is way larger than the simple linear regression model. So that's we believe our multiple linear regression model fitting the data better. Okay, so this is the answer for